The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Okay, now we're going to take a look at force of friction and normal force. Okay, if you have two objects as such, right, and you have a force applied coming from the right, as we see here, and you push an object to the left, there's going to be a force that opposes that, and that force is the force of friction, as we see here, and the direction is given by this arrow, right? It's opposing the force applied. Now, if you were to actually take a look at a view of the two surfaces, right? A closer view, a zoomed in view of the two surfaces, right? As we see right here, what we would actually see is when you initially place the two objects on top of each other, right? You're going to have microscopic connections between the two objects, as we see here, right? Now, as there's a force applied, so when there's a force applied and you're pushing this box to the left, right, what ends up occurring is these microscopic connections, they actually break and they adhere, right? So they're breaking and they're adhering, and that's what is being demonstrated right here, and that is your force of friction. Now, what ends up occurring is if you want to find the force of friction, you can do so through the following equation, where it's this symbol here times normal force. And what is the symbol here? Well, let's take a look here at our first bullet. That symbol there is actually pronounced mu, right? And it is the coefficient of friction. So that there is the coefficient of friction. And what else can we know about the coefficient of friction? Well, let's take a look. The smaller the coefficient of friction, or mu, is, right, the more slippery the surface will be. Okay, great. Now, because one other point about mu is, since mu is just going to be the ratio of the force of friction over the normal force, right, that is why that your coefficient of friction is actually a dimensionless quantity, right, and it has no units. And that's what our last point here is telling us, that the coefficient of friction is a dimensionless quantity and it has no units. Okay, great. Let's actually go ahead and build on this on our next slide. Now, the force of friction continued. There's two types of sliding friction. You're going to have static friction, right? So that's at rest, and kinetic friction, right? That's going to be with movement. Now, generally speaking, static friction is actually larger, or greater, you could say, than kinetic friction. And that makes sense, right? Because when an object is at rest, it's actually it's harder to get it moving, as opposed to when an object is in motion. And that's what's being depicted here. Wonderful. Now, two other points that we should take a look at here is when the object is sliding, right, then you're going to use the coefficient of kinetic friction in the equation, and then when the object is at rest, that's when you use the coefficient of static friction. And just to give you a few examples, here is the coefficient of static and kinetic friction given to us for synovial joints, wood on wood, and steel on steel. All right, great. Let's now build on our discussion and the next slide. Okay, now we're going to take a look at, all right, up to this point, we've been taking a look at friction, basically, as it basically brings an object to rest. But now we're going to take a look at and see how friction is actually needed for us to walk. Now, looking at our diagram here, right, more specifically, it's static friction between your foot and the ground that's actually needed for you to walk. And to be more specific, at the end of your stride, right, at the end of your stride, your foot is actually momentarily at rest, and what it does is it's going to push back. And when your foot actually pushes back, it's the ground, right? It's the ground that pushes you forward as such. And let's just say you're on a surface now where you actually, so that there's supposed to be the ground, it's supposed to be straight. We'll make the assumption that it is. Now let's just say you're standing on a frictionless surface as such. If you're standing on a frictionless surface, you're actually going to start slipping all over the place, right? And it's actually going to be very, very, very difficult for you to walk. So it's basically what ends up occurring is you need that friction just to move along with your strides. All right, great. Let's actually do an example now on the next slide.